Okay, welcome back. Topic 9, Lesson 3, Day 2. Today we're going to continue that work that we did yesterday, writing radicals. Today we're also going to include multiplying those radical expressions. So you may see radical expressions that are spread out, where then you have to combine them back together to make one radical expression, and then simplify it from there. So, the first example we're going to do is 3 times 5x times 2 times 15x cubed. Now, remember, all of this is being multiplied together, so the commutative property tells us that we can actually rearrange this so that they are next to things that are alike to them. Because it's all multiplication, we can rearrange that. So we actually want to put the numbers that are alike next to each other and the radicals that are alike next to each other. Okay? And we can actually kind of like multiply these out. So I'm going to rewrite it so that it's 3 times 2. And then I'm going to rewrite it 5x times 15x cubed. Okay, so 3 times 2 is 6, and I'm going to multiply this out. 5 times 15 is 75, and x times x cubed is x to the 4th. So now I want to think about how can I break these down. Remember, I'm going to ignore the 6, leave it out front. Sorry, and I'm going to write a little note right here. Then we're going to simplify. So I'm going to rewrite this. That 6 is going to just stay out front, and I'm going to rewrite it as something that's perfect times whatever's left over that's not perfect. Okay, so I'm going to simplify this. I know from yesterday that 75 is divisible by 25, which 25 is a perfect square. So I'm going to write 25. And I know that even exponents are perfect squares, so I'm going to write all of x to the 4th in there. And what I'm left with over here is just 3. So then I can simplify from here. The square root of 25x to the 4th is 5x squared, and I still have the square root of 3, and then I multiply 30x squared times the square root of 3. Okay, let's try one more. I'm going to do it over here. 1/2 square root of 21x cubed times 4 times 7x squared. Okay, so I'm going to rewrite it so that I have my numbers next to each other, and my radicals are going to be next to each other, and then I can combine them under one radical. So I have 1/2 times 4 times the square root of 21x cubed times the square root of 7x squared. And then I'm going to combine those. So 1/2 times 4 is 2. And this becomes the square root of 147x to the 5th. Okay, and if I remember correctly, we were looking at 147 yesterday. If I want to simplify that into perfect squares and non-perfect squares, I believe that I can divide by 49. I can. So 49 is a perfect square that goes into 147, and I'm going to keep all the even x to the fourth in that one. And then I'm left with 3x over in the non-perfect radical. So when I simplify, I'm left with 2 times 7x squared, square root of 3x, and then I can simplify that to 14x squared, square root of 3x. Now, I want you to try one by yourself on the left-hand side. And so I want you to pause the video for a second once I get this written so that you can try it. And then you can look at my picture of this example when you're done and be sure that you did it right. Now I want to remind you that if there is no number in front of the radical, that is the invisible 1. Okay, now that you've done that and you've checked yours with my picture, which is on the Google Classroom assignment, I want you to go on to enVision and I want you to look at example 5 from section 9.3. I'm calling it example 2 in my journal, but it's actually example 5 in the book. So I want you to go through there and look at example 5 and then come back to this place in the video and we'll continue going over it. So in that example, we are looking for the slant height of, we're looking for the slant height of the cone. And we're going to use the formula that they give us to help us find that. And that is the square root of r squared plus h squared. Now, they told us that the radius was just r, and that the height is 7 times the radius. So I'm going to plug 7 times the radius in for the height. So the square root of r squared plus 7r squared. Now, when I square 7r, 7r times 7r is 49r squared. And I combine like terms. I have 1r squared plus 49r squared, which is 50r squared. Now, I want to simplify that, and again, I'm going to break that up into everything that is a perfect square times everything that is not. So I know that r squared is perfect, and if I break 50 down, I can break it down to 25 and 2. 25 is a perfect square, and 2 is not. So when I simplify that perfect square root, I get 5r times the square root of 2. Now in that picture, it says that the radius of the cone is 3 inches, and they're wondering if it will fit on the wall as long as it's not longer than 24 inches. So if r is equal to 3, we can plug that in. 5 times 3 times the square root of 2. And we get 15 times the square root of 2, which is about, because 2 is not a perfect square, it's going to be an irrational number. So 21.21 and so on. So we know that this is less than 24 inches, so that it will fit on the wall. So the slant height is about 21 inches, which is less than 24 inches. So it fits.